Hi friends, welcome to another episode of Decluttered. In today's episode, let's look at this very interesting permutations and combinations question. Let me explain the question and then pause the video for a couple of minutes. What happens is, we have n chains of balloons and each chain has A1 balloons, A2 balloons, A3 balloons, so on. The nth chain has An balloons. Now, we have to find the total number of different ways in which all these balloons can be shot at, provided if you have to shoot a specific balloon, all the balloons below that should have already been shot. I'm not saying that if you want to shoot, let's say, the second balloon from the bottom in the third chain, you need to shoot the bottommost balloon of A1, A2, A3. You need to shoot the bottom balloon of A3 alone. Attempt to solve it before you come back to me for the solution. Alright, let's look at the solution to this excellent question. It's very obvious that we have a total of summation AI balloons where I ranges from 1 to n. So the total number of balloons that we have is A1 plus A2 plus A3 plus so on up to An. Let's assume that I was able to arrange these balloons in a straight line. So the number of dashes that I would have would be summation AI, I equal to 1 to n, and the way I need to shoot the balloons is in a way equivalent to how the balloons appear from left to right. So we know that the number of ways these balloons could be arranged in a straight line is represented by that factorial. But this involves all the arrangements without taking into account that the bottom balloons need to be shot before you are shooting one balloon at a certain level. To account for that, let me do one thing. Let me assume that all the balloons in the nth row are of one color, all the balloons in the other row are of another color, and same way all the balloons in the other row are of another color, and that way. Now, given that I have chosen n different colors and each row has these balloons of the same color, if I had to look at this in number of ways I could arrange this in a straight line, it would eventually boil down to summation AI factorial divided by product of AI factorial. Since these are of the same type, A2 factorial, A1 factorial, when you have to do combination, right, or when you have objects of the same type. Now, the claim that I am making is, this is the total number of ways I can actually shoot the balloons meeting the criteria given in the question, because if, let's say, I have the purple balloons or let's say the red balloons arranged, by dividing up A2 factorial, I have equated all these balloons, and it doesn't matter because I will always treat this as the lowest balloon, this as the second lowest balloon, and so on. And that is how this question is essentially a combination question. Another way of looking at this question, let's take a simpler example, right? Let's say that you have totally 8 balloons, the first one being 3, second one being 2, and the third one being 3. So my claim is the total number of ways that you can shoot this is this, given that these 3 balloons are of one type, these 2 balloons are of one type, and these 3 balloons are of one type. The other way to look at the question is, I have 8 dashes Out of the 8 dashes, I will choose any 3 for the first type of balloon and arrange it in A1, A2, A3. Out of the remaining 5 dashes, choose 2 more dashes for the second row, and out of the remaining 3 dashes, choose the 3 dashes for the third type, because the balloons have only one way to arrange and the interarrangement of the balloons do not